package info as opposed to query info. Query info queries packages in the database. So dumps information about the nano package as it's recorded in the local RPM database. However, as a sixth option, RPM query package info followed by the URL that we've just pasted dumps info about the uninstalled DHCP package which resides on the repository. That's the HTTP repository. The information is similar to what you'd see when you execute RPM query info against a package that's locally installed. It includes the name, the version, the release by Red Hat, the vendor, the build date, the install date. It's currently not installed. The build host. Usually it's a box at Red Hat. Other important information: size, the group where the package belongs, the source RPM or the RPM package that was used to create this package, the binary RPM, the packager, the signature, description, summary, so on and so forth. So you can query a package before installation. That's the purpose of using the RPM query package info options. Now again, no need to memorize all of these commands. Ideally from the shell, if you can execute RPM followed by -- help, you'll see the myriad options that are available, including query, freshening, the ~F option, upgrade, installation, removal, and other options. The RPM package or the RPM program offers many such options. Now let's move on to verification. You can verify all of the packages on your system quite easily using RPM uppercase V followed by lowercase a. Uppercase V means to RPM that it's to verify whether it's the packages in your database, the RPM database, or a package on your file system or on a remote file system such as an HTTP accessible location. So verify all navigates through your database, checking all, in our case, 929 packages to determine whether or not the integrity of the packages are intact. In other words, to ensure that what was installed is what is actually reflected on our local system. This is a quick way to determine whether or not packages have been upgraded, changed, or tampered with. Only if there are issues that don't reflect the original system configuration will you see output. So for example, what we see here is some output related to items that were created as a consequence of installation. So these are additional items, like the etc.ssh moduli file, for example. These messages are perfectly fine. We'll let them come back. However, if you see any discrepancies related to a package, specific package, let's say nano, such as a signature issue, an MD5, SHA-1, or signature issue, GPG issue, then you know you've got a problem. There's some sort of compromise or change to that package on your system. So the general VA option scours all 929 packages or the full package database to determine if there are any problems. And if there are any blurring issues, you'll see them on the screen. These are small. These usually reflect files that are created as a result of package installation and are generally not important. You may also verify files directly, such as, let's say, grep. And let's just indicate that this verifies all packages on the system, returning information only if there are discrepancies from the original installation. Now to verify a file, RPM-V, uppercase V, that is lowercase f, just like you'd use when querying a file directly, followed by the path to the file, such as user bin nano. This will verify whether or not nano has changed. Again, the verification process takes into account GPG as well as SHA-1 and MD5 technologies. Now let's just kill this full verification for a moment so that we can reuse the shell. We use Control-C to kill it. Clear screen, and then RPM verify the nano package. And if no output is returned, that means the package has passed the test. However, if we were to compromise the user bin nano file purposely and then attempt to verify the file, the RPM verification process would detect a change based on one or more attributes such as MD5, the file size, whether or not the mode or permissions has changed, and so on. So, task, change user bin nano, then verify. So to do so, we'll move the existing copy of nano. Let's SU in first, however, as we'll need full rights to be able to do so. Then navigate to user bin. So we'll move nano to nano.old. Then we'll sequence 1,000,000 nano. And even if we were to create a nano file that's the exact size of the original binary, and even if we made it binary using DD, for example, RPM verification would be able to detect the difference or the discrepancy. So now using RPM uppercase V lower F followed by user bin nano, you'll see that it'll pick it up momentarily. Now we see some output. And what does this all mean? Well, let's copy it and translate. So this returns SM5, a bunch of dots, T for the file. Well, there are various status codes that may be returned, and this is included in the RPM documentation. S means the file size has changed from what was or what is in the database. So in the RPM database is an entry for the file user bin nano, and the verification process is telling us, or has told us, that the size no longer matches. M means the mode or permissions have changed. So mode or permissions. For example, maybe the original file was flagged 755, and now it may be flagged 644, so on and so forth. 5 means the MD5 sum no longer checks out. And T means that the modification time is no longer the same as what is recorded in the RPM database. So there it tells us that there's a problem. Now let's echo the exit status. You see that it's non-zero, indicating that the verification process encountered a problem. To rectify the situation, we'll remove RF nano, that's the new corrupt version of nano, and then move nano.old back to nano, then rerun RPM verification against nano. Now the exit status is 0, everything looks clean. So you can use RPM to determine whether or not any of the RPM related files have changed. Now again, we did mention that each entry is maintained in the RPM database. You can RPM query list, for example, nano, to see the contents of each package, of which you'll also find the nano binary user bin. And within the RPM database are fields, important fields such as size, MD5 sum, whether or not it's a symlink, modification time, the mode, user and group, so on and so forth. All that information is stored within the package, and that's how RPM is able to check and to determine whether or not anything's changed with a file. So that's how you go about using the verification process to verify files. You may also verify packages using the uppercase V and lowercase p options. So for example, RPM VP nano will attempt to perform a verification on nano against what's installed on the system. In this case, we need an RPM, so we could link to the original RPM, wherever it happens to be. If you just do VP nano, nothing's returned. However, if you specify a source, such as the one in our Firefox browser, let's find nano here, and copied the link location, then attempt to RPM VP the link location, this performs a test against it, and it determines if there are any issues. A warning was returned, however. How about in the remote system? If we RPM VP, just to see if there are any differences, and it returns a warning as well for this version of Nano. Now let's move on to another mode of using RPM, and that's to install packages. We execute an installation using the I option. That's lowercase I. You may optionally turn on verbosity, which is lowercase v, and hash marks using H, followed by the name of the package, one or more, and RPM will attempt to install the package. Now, RPM automatically handles dependencies, so let's list that as a third feature. Automatically reports on unresolved dependencies. So it knows, based on the contents of the package that you're trying to install, the other packages that are required for successful operation of the package you intend to use, and will report to you as such. So if you try to install a program or a package which depends on another package or program, RPM will complain, indicating that you'll need to install the other package, which you can do on the command line along with the original package. We need to find programs to install, by the way, so let's take a look at a package repository. We'll just Alt-Tab, and we'll install that DHCP package. This is the server package. We'll uninstall it in the removal section momentarily. So we'll copy link location again. Just make sure Firefox is in view, and then from the shell we'll use RPM and specify the HTTP URL. Again, we need to be root in order to do so. Now we're installing this on a remote system. That's fine. It will install just as well, and it will also install locally. IVH followed by the name of the package does the trick. If all goes well, the package is installed. And the warning was thrown because we had no key, or we don't have the GPG key imported. It's not imported by default. And the warning was thrown for the verification as well, because of the same reason. So as an example, RPM IVH installs packages. However, the installation process overwrites, or does not overwrite previous, whereas the upgrade process overwrites. So install does not overwrite previous package. And this is why the installation method, which means using the lowercase I option, is the proper method or ideal method for installing the kernel. So note, use this method to install a new version of the kernel. So if you get a new kernel package from the Red Hat network or from a Yum repository, use IVH instead of UVH, which we've yet to look at, because the installation option indicated by I ensures that the package is not overwritten, meaning an existing version of the package is not overwritten. So if we had, let's say, version 2.6.13 of the kernel and we receive 2.6.14, 2.6.13 will not be removed. So installing a program is very easy, especially when there are no unresolved dependencies. We see the